Hey guys, how's it going? Today in this video we're going to review some energy transformations, that idea. I'm going to give you a couple examples and have you work through them, or you can just sit there and watch me work through them by myself, that's fine. And we're going to briefly touch on energy bar graphs. So that's kind of what we got on the agenda today. We're going to go not into the room, we're going to go into the storage room first because why not? Actually, I have a reason. So sometimes you guys have heard noises that sound like they're coming from above us or in the back of the storage room. It's because they are. And my first energy transformation question for you is fireworks, because I keep fireworks in my storage room, and sometimes they get volatile. That's on the shelf right here, and like that one does, just light and explode for no reason. So sometimes you'll hear just this noise, an explosion. I also make the red ones too. So sometimes they just blow up, and that's what we hear um, going on every day. So, what type of energy transformation do we see with fireworks? That's the question that I'm asking you today. So, hopefully, you can think that one through. If you need to pause the video and kind of like, get that one down, feel free. But the main energy source at the beginning should be fairly easy, hopefully to us, and that is boom, potential chemical energy. So the stuff that these are made out of, the fireworks are made out of, are designed to explode. They have the chemicals inside those bonds ready and willing to blow up. So that's potential chemical starting. Now, fireworks are a little bit easier for what they're going to, because there's kind of a lot, right? If I light a firework and look at it, well, one, I can see it. I can see the visible light that's produced with fireworks. So right away I know that kinetic light is something that's produced. Also, I can hear, the big booms that they make, so I know that's going to be a kinetic sound for sure right there. Um, Depending on what I'm blowing up, maybe I'll see some kinetic mechanical. It's definitely possible to see that if the bits of the shells are pushed apart. Or if I get too close, or it's a really big firework, there can be some thermal as well. So that one had about 4 different ones that it could go to. So put this back. But before I do, here's what it would look like if Mr. Parmley just like lit fireworks under table, let's say table 1's talking too much, and I did that. It would just, that's what it would be like. It would be really loud, and there'd be explosions everywhere, and fireworks in the room. By the way, the school does not approve of me shooting off fireworks in the classroom, so I won't. Don't worry. We'll just put that one away from that. Stick it in my pocket. Alright, so now we're going to actually go field trip to the cafeteria. That's where we're going to go today. The cafeteria, and it is, wow, I fell into a different world going to the cafeteria. That is very strange. Wow, gosh, it is dark here in this new world. And how does grass eat? That's the next question. That's the next energy transformation. Well, certainly one thing I need is this thing right here. I need the sun for plants to grow. We all know that. We should have learned that a process called photosynthesis is what plants use to feast on the light of the sun. So right there, we've kind of said everything we need to say to convert it into our energy terms. So I know my initial spot is actually the light coming from the sun. So that kinetic light, or kinetic radiant energy that we get from the sun, that's the initial. And then what's it transformed into? What does the plants turn that into? Well, they store it inside of them, and so there's your hint, store. And so since light is plants' food, food is a type of chemical energy for us and for plants as well. So the overall transformation for how trees and plants and grass get the nutrients and grow is kinetic light to potential chemical. Then they turn that chemical energy into other things later as they need it. Let's move on. So Mr. Cow here, we've learned from previous videos that cows in fact do have mass. We saw that in a previous video, as I mentioned. We're also aware of that he is above a canyon, not a very deep canyon, maybe 5 blocks or so, and then that looks like over a hole as well. Again, a really shallow hole, maybe like 2 or 3 blocks deep. So nothing he can't handle. I'm pretty sure I can see some water down there, so he'll be totally fine. But the main energy that he has from having mass and from having from standing at such a height and from being on a planet with gravity, as we see, because I fell back down to the ground just then. So if I were to push this button, let's see what his energy transformed into. Oh, I saw him move, so we've said before if I can see it move, then it must be mechanical. So that one is a pretty simple one. You probably all got that. Potential gravitational to kinetic mechanical. So let's hop on over here. Oh, I made the jump. Now this next one, before I talk about it, I want to briefly mention redstone is something that we've used before in Minecraft, and we said that it represents our electricity and our wiring that we use every day in this world. So when I step on this plate right here, it's going to activate, and if I look, I can actually see the light. I can see the light moving. That tells me that the redstone's working, and just as a parallel to electricity in the real world, the lights move, or the electrons move for me. So this goes back to a big concept I want to make sure we all hit, is that electrical energy is always kinetic. It's never potential. If I stand on this plate in Minecraft and then leave, it doesn't just turn on automatically. We have to use things like switches to complete currents to get a constant flow of electricity in order to have steady power for anything. So that is true of our world, and so there is no such thing as potential electrical energy. So be careful about that. That's potential electric does not exist. Kinetic electric does exist. So don't get those confused because it's easy to do that. That having been said, now let's look at this example, or maybe listen to this example is a better way to say that. So we know before, because I just told you, that this is kinetic electrical energy. I can see the lights moving, I can see the electrons moving in this example, and I can hear the result. So that is something, if I can hear it, and that's the main thing that I'm listening to, that the main point of that was that I know that it must be kinetic sound. There's nothing else for it to be. So again, kinetic electric to kinetic sound. Let's walk across this tree that probably was chopped down in a fire, so that looks like it's worth it to me. Here's looks like a hint. It says kinetic electric to kinetic mechanical. We just learned over there that this must be our electric, so I bet that's what I stand on. It's going to activate some sort of mechanical thing. So let me just go stand on that and see what happens here. Okay, so there's a cow on a mine cart, and that's neat. I wonder what's going to happen next. Oh dear. Oh wow. So there used to be a tree here. Okay. We're just gonna move on. I don't need. It's not good to litter, boys and girls, but I'm going to get away. Maybe for I should light a firecracker for in memory of the cow. All right. I'm sure he's happy now. All right. Let's actually look at that in more detail over here. And yes, I burned down several trees to get the space to do this. Just be quiet, sheep. So anyway, this is a quick example of a bar chart. So in the beginning, we're going to talk about just the tree there. Some of you might have figured out, you might be suspecting that I think there was some TNT hidden somewhere around or inside the tree, and you would be correct. There was, but we're not going to look at the TNT. We're just going to focus on the actual tree itself. So in this respect, we know that trees do not just commonly explode. Very fortunate for us. So in the beginning, in the initial state of my tree and my lack of tree, I know that there was no energy. The tree was just standing there. It wasn't doing anything. Now, yes, it had its own potential chemical energy, but that energy did not factor into it blowing up. So it was just there, being a happy tree, and then at the end of it, well, we know that I definitely heard stuff, and I saw pieces flying over, so there's my kinetic, mechanical, and sound kind of combined into one. And There was probably some thermal as well. Um, Nothing burst into flames, so that's good. So I know there's not a whole lot of thermal, but I know from explosions that there's typically always heat within an explosion, so it's not a bad idea to put that in there. Those other two ones that are not here, those are blank. There was no elastic energy and there was no gravitational energy. Nothing was raised. The mass was not raised high. It was really, the mass was obliterated. But looking back at this, I've mentioned that it's kind of like a math problem, and we need to make sure that it works. So we've talked about the beginning, which is 0. And we've talked about the end, which is 1, 2, 3, 4 blocks. Now we need to talk about how to get from 0 to 4. And you've all done this math before. And 0 plus 4 equals 4. Look at that. You are on top of it today. So this middle part here, we have the square, which represents our box, as we've said before. And it's going to be used by us to tell where the energy came from and what happened. So this energy needs to be added into the system, because if the tree did not have any, in order for this to balance out, in order for this equation to make sense, I had to add 4 to get from 0 to my final total count. So that's why I picked this. I put 4 blocks here. And then now, when you're telling me this, you don't need to be this specific and say there were 3 blocks of mechanical and then 1 block of thermal. You just need to tell me there's 4 total blocks coming in. But I broke it down just so you could kind of visualize what's going on. And so I draw an arrow showing which direction it's going into the box, so I draw the arrow point in the box. And I need to say where it's coming from or where it's going to. In this case, the energy came from the dynamite. It came from the TNT and went into the tree, and now the tree used to be over there. So that's a quick video about bar graphs and energy transformations. I hope it helps. And let's do one more firework just to celebrate that the video's over. Huzzah! And of course we need this in midnight because that's just more pretty. So yay, you made it to the final end of the video. Congratulations!